What's going on? This is SDG Physics. My name is Tosh Dalday, and I like Batman. What up, dudes? Does this make me look nerdy to you? We're going to be covering this thing called an Atwoods Machine. It's actually by this dude named Atwood, and he was a tutor, a physics tutor, and he actually made this device to kind of help people understand physics better. Turns out that it's actually a very, very helpful device. Let's take a look at it. It's a pulley with a mass 1 over here and a mass 2 over here. And I think what I'm going to do is, that's all it is. And depending on mass 1 and mass 2, it kind of goes like this or goes like this. This one goes up and this one goes down, or this one goes up and this one goes down, depending on whether mass 1 is bigger than mass 2 and whatnot. Let me try to solve for the acceleration. Let's figure out the acceleration. So let's catch the forces that are on this thing. There is the weight of this object, so that's weight 1, and then there's the tension. That's all the forces that are acting on this thing. So if we add the forces in the y direction, that's going to equal to mass times acceleration of 1. So this is mass 1, A1. And so what we can do is we can just say, well, if I'm going to add the forces, I see the weight 1, which is going down, and I see the tension, which is going up. I'm assuming I'm calling this to be the positive y direction. So we've got negative weight 1 plus t equals mass 1 times acceleration 1. Now let's figure out what the tension is. Well, I can turn to this one and I can say, well, this guy's pulling down with weight 2 and this guy's pulling down up with tension. Now here's the funky part, is actually this weight 1, even though it's pulling down on this direction, it's actually going in the positive y direction. The reason why it's going in the positive y direction is because of this pulley. Pulleys kind of bend your coordinate system around. If I have my y-axis, y pointing up for things that are going this way, then when I go around the pulley, it kind of goes things that are going up. I mean, if you think about it, if this mass 1 were going in the positive y direction, let's say it's going up like this, then this mass 2 would be going in the positive y direction as well, and it would be going down. So in that case, this would be positive W2 minus T equals M2 acceleration 2. And I'm just going to solve for T, so I have W2 minus M2A 2 equals T. I don't know why I put A1 and A2, because the acceleration of mass 1 and the acceleration of mass 2 is going to be the same. I'm just going to erase all of those subscripts on the A's because they're all the same A. The acceleration of this guy is the same as the acceleration of that guy. Alright, let's see. I'm going to take this T, I'm going to plug them into here. So I have negative W1 plus W2 minus M2A equals M1A. Alright, let's solve for A. So I'm going to do, by the way, the W is mass times gravity, so I've got negative M1G plus M2G equals M1A plus M2A. Factoring out that A, I basically can just kill that A and then put a parentheses around here. Then divide both sides by M1, M2. And so here's what I'm going to do is A equals M2 minus M1 times G. That would be that guy right there. I just factored out a G. Divided by M2 plus M1. Alright, so this is saying if M2 is bigger than M1, this will be a positive number, because a bigger number minus a smaller number is a positive number. And therefore, the acceleration will be going in the positive direction. That's what it's saying. If M2 were smaller than M1, then M2 minus M1 will be a negative number, and this acceleration is going to be negative. Therefore, the whole system is going to be going in the negative y direction. So that's your answer right there. That's the Atwoods machine.